this is the coding kata section, and in a coding kata, what we do is we practice test-driven development, so that we build a little piece of.
And you got 5 minutes. 5 minutes behind.
So we build a little piece of Ruby code, and we do it by writing our tests first, and then writing the code to satisfy those tests. And this is a great way to program, and by practicing it in katas like this, we can get comfortable with it, and it won't slow us down when we need to do it for real. So today I'm going to be doing the same type of kata that Jason did the last 2 times. It's a kata about parsing serial data. In particular, this serial data is MIDI. And,
what have I done?
And we're we're going to parse the SysEx messages out of it. And the way that works is you're receiving this stream of bytes one at a time from MIDI, and there are these special messages embedded in it. And the start of the message is denoted with a hex F0 byte, and the end is denoted with hex F7. And we just want to look at what's between those bytes. So first of all, we start off by writing a test to describe what this code is going to look like. I think we should have a class named SysEx. And we will describe what the class does. And we should have some really simple base test for it to start us off. So in the context where, with no input, it should report no messages. The basic thing is that it needs to tell us about the SysEx messages it's received, and before it has any input, there should be no messages. Oh, I'm going to try really hard to use the expect syntax, because that's new and shiny. So we expect SysEx.messages to equal an array. One problem is I didn't actually define what SysEx is yet. That's going to be the subject of our test, so we use subject, SysEx, and we could just say SysEx.new. I kind of like to be fancy and do described class.new. All right, anyway, we have our first error now, uninitialized constant SysEx. So that means that the SysEx class didn't exist, or either my code wasn't able to load it for some reason. We actually need to define that. Oops. We need to define that class. So class SysEx. Now we have a different error message, and this one's nicer because it comes from RSpec. So expect the SysEx messages to be the empty array, but there is actually no method called messages. So I already know I just want to make this thing be an array that you just directly read. So I'm going to make this at your reader, and that will allow you to call .messages on the object, and it'll look for the messages instance variable. And we should initialize that messages instance variable in our initialize method. So when the object is created, the messages will be set equal to the empty array. And something is failing still. All right. Oh yeah, I used the wrong syntax here. It says the expect syntax does not support operator matches, so you must use 2. So we have to do the 2 EQ. That should be equivalent to the double equals operator. So now the tests are passing. And let's do another quick base case. Just if it receives some input that doesn't have a SysEx message, it should also report no messages. So with an input that has no SysEx messages, it reports no messages. It's kind of the same as what I just typed earlier. But we actually have to give it input. See, I didn't actually do what I was saying I was going to. So SysEx.bytes, let's just give it some some bytes that don't have a SysEx message. And now we have the error, undefined method bytes. So I want this bytes thing to be the way that we pass the data into it. And I want the interface to be that we pass an array of some number of bytes whenever we receive some bytes. So I have to define that bytes method. And it takes a byte array. And we don't actually have to do anything with it yet to get our tests to pass. I just save, and my tests automatically run, and everything's good. Now, time for a real thing. So, context with one SysEx message in the input, with just one SysEx. I'm just going to send the message, no caddy. I want it to get it properly. So it reports the one message. All right. So now let's actually send a real message. So we'll start it off with an F0, then we'll have 8 and 9, then we'll end it with an F7. And I'm expecting that I get this array of messages, and there should just be one message in it. That message itself is an array, and it should have the bytes 8 and 9. All right, now we actually have to implement some real functionality. The code is saying, well, I expected you to give us, to report this message, but I just got the empty array. So the first thing I want to do here right away is I don't want to get messed up by the details of how the bytes are actually grouped into arrays. At a high level, what MIDI really is it's a series of bytes. It's a serial stream of data. A byte comes after the last byte. And the stream of data itself doesn't have any type of packets in it. What we're doing is we're parsing out the packets. But this array here is not meaningful. The only reason we're getting these bytes in an array is that's because how these low-level drivers tend to work. For efficiency, they want to group up a whole lot of bytes into one chunk and send that. And when they send that chunk from one context to another, they're sending it all at once. So what I want to do is just iterate through each of these with .each. Let's get each byte, and then we'll process each byte one at a time. And we need to have our process byte method, and it takes one byte as an argument. So by setting up the architecture like this, I know that I'm not gonna, it'll be impossible for me to make any bugs that are based on how the bytes happen to be chunked up into different arrays. And so that means I don't have to write lots of different tests for different types of chunking. So now in this process byte thing, what do we have to do? Well, to make this message get parsed, we kind of just have to write the whole thing. So we need to define what our start byte and stop byte are first, because we'll need to use those, and it's nice to just have constants instead of magic numbers. So if the byte we get is a start byte, we should start recording the message. And so we'll open up, we'll make a new array. This will be the message. We'll set it equal to the empty array. The next thing that we're going to receive is some data. So we need to write the code for processing that. So if we just get some general data, we want to add it to the current message. And when we get the stop byte, that's this other case that we should add up here. So if the byte equals the stop byte, well, now we've accumulated the whole message inside current message. So let's just add it to the messages array. Oh, some error. Undefined method less than for nil class. And that's on line 23. So 23, current message. Oh yeah. So that's in our earlier test when we were just giving it a general input. And the reason that is a problem is because this current message thing is nil because we never started a message. So we should really check to see if current message exists. And now that I've done that, the test passed. So we was actually able to parse the SysEx message. But there's still another bug in here. After we have added current message to the messages array, we should really set it equal to nil so we're not tempted to keep on modifying it. But we don't have a test that reveals that bug yet, so we should write that test before we just fix it. So I'm going to write a more general test. And it's going to have 2 SysEx messages and other data. So it should report the 2 messages. And now, what are the bytes? Well, I want to make this a more general case, so I don't want to just start off with a SysEx message right away. I want to have some other data, then a SysEx message. Then, after the SysEx message, let's have some other random data interspersed in it. And then another SysEx message. How about the number 9? And another byte at the end. Just make it more general. And, oh yeah, I have to actually make an assertion. So expect sysex.messages to equal the 2 messages. We got these two messages in that. All right, so you can see this error here. The messages it's recording have been modified after their stop byte. 7, the message was supposed to be 2.3, but it ended up being 2.3.7 because at this point, when it processed this byte, it still had the current message array inside that instance variable. It still held on to a reference to it. So we need to fix that, and it's pretty easy. Just set this equal to nil. And this brings up a general point in Ruby. When you add an object to something, you should be worried about what might happen to that object, because arrays and strings and hashes, all sorts of things like that in Ruby can be modified, and you should worry about who's going to be modifying them. Unless you be very strict and do everything in a functional way. All right, so now we've set that message to nil, and everything's great. This is a general purpose SysEx message parser. I think I haven't handled some of the special cases that Jason handled, like what if you get an F0 byte in the middle of it, but we could handle that. But I'd rather show a couple different ways to implement this code. So this is iteration 1. And I was looking at this and I thought, well, what we're doing is we're getting a byte. We're getting 1 byte at a time, and we have to process it and we have to return. We can't do anything like ask for the next byte. We have to just wait until the bytes come, and we just have to accept that they're going to come later, and we have to return control back to whoever called this method. But it doesn't have to be that way. Wouldn't it be nicer if we could have this function called receive bytes, and it is in control, and it is just in a loop, and it can decide when it wants to receive a byte. So it can just call next byte to get a byte. And if the byte is equal to the start byte, well, then it should get more bytes. So it would say current message is the empty array, and while, so this is kind of tricky, but we're going to do while we get a new byte, and that byte is not equal to the stop byte. So it'll get all the bytes and add them to our message. And then at the end, after we've broken out of this array, we know we received the stop byte, so we can just add the current message to the messages array. So this is, I haven't made this code work yet. I'm just showing what I would like to achieve. And the tests are still passing because it's using the old code, but we're going to make this code work pretty soon. And what's nice about this code is that you can look and see all the steps for receiving a SysEx message in here. Just scan down this page line by line. You see exactly what the code is going to do to receive the SysEx message. Another nice thing is that this current message can be a local variable instead of an instance variable. You might say that, you might argue that's bad because it makes it hard to inspect the state of your object, but it's also nice because it's a local variable and it cannot be modified from as many places. It's nicer to keep your variables in a smaller scope. Anyway, how do we make this work? We can make this work using a cool thing called a fiber. The way a fiber works is that it's just built into Ruby. It's part of Ruby. You can do fiber.new. It's kind of like a thread, but you have much more control over when exactly it runs. So we can say, let's make a new fiber, and the code that this fiber is going to be running is, it's just going to be calling the receive bytes method. And the fiber doesn't run yet until we actually tell it can run. And the way that we'll tell it to run is when we're iterating over the bytes, just say fiber.resume and give it a byte. At that point, when we call fiber.resume, the fiber will start running. And it will have access to this byte. And the way that the fiber can read the next byte is that the fiber has to yield control back to the main program. So when the fiber is running and it calls next byte, it'll yield back to us, and then the program will keep executing here, and it'll either give the fiber the next byte or it'll just exit. So we can run this, and actually, most of the tests passed. One of the tests is failing, and that's the SysEx with just one message in the input. I made a little error here. the first time I call resume, the fiber is going to start running, and it'll start running at this point, and so that first byte actually gets lost. I think what we should actually do is call fiber.resume here. And then that starts the fiber running initially, and the fiber will run until it needs that first byte. At the point where it needs the first byte, it calls next byte, and that yields it back to the main program, and then the main program will pick up where it left off. So by just adding that fiber.resume, we can fix that, that page down in my shell, and there, now it's fixed. All right, so now we have these two different things. This code is not being used. I'll remove it shortly, but I wanted to show them on the screen as the two different interfaces that we had. We were given this interface where we just processed bytes when they came to us, the process byte interface. And using a fiber, we were able to turn this into the receive bytes interface, where we just call next byte whenever we want to get a new byte. And that's this kind of thing is called a code routine. And I'm not saying it's a magic bullet or you should like always be using it, but maybe it'll make your particular application, maybe it'll make it easier to express the logic in your application. And now let's delete the old process byte. So long. And the test still passed. Now one thing to worry about with fibers I just want to show is that your ensure blocks don't actually get run. Just when the fiber gets garbage collected, like it doesn't do anything special. It just doesn't run that code again. So that should maybe make you a little bit worried. You should usually you want to know if you're running code inside a fiber and be aware of that sort of thing. All right, so this is iteration 2. We have 8 minutes, so there's totally time for a third iteration. And in this iteration, I want to make all this code be one line. This is definitely starting to be overkill, but I think it's fun and it shows how the Ruby language can do some cool things. So the enumerable module has a method very much like what we are doing here. Enumerable, I mean, wouldn't it be nice if we had some sort of stream object that acted like enumerable? And we could just call take while. And what take while does is you give it a block, and it'll wait until the block, it'll pass each element in the enumerable to that block. And when the block returns a false value, it'll stop, and it'll give you a collection of everything before the false value, all the elements before that made the block evaluate to true. So we can just say stream, we should be able to just say stream.takeWhile while the byte does not equal the stop byte. Let's actually call that, let's write that out. We have some words on it. And this will return an array with all the bytes in it for our message. And we should just be able to add it to our messages stream. So how are we going to get that iteration to work? Well, I think we should have the stream object come as an argument to receive bytes. The receive bytes doesn't have to know the details about how the stream is made. And if the stream is responsible for things like take while, it should also be responsible for simple things like giving us the next byte. And so the next byte will not come from here anymore. So how are we going to get this next byte? We just need an enumerable module we just need an object that behaves like an enumerable, but it calls fiber.yield. So we need a fiber yield enumerable. And so we can just do this, it turns out. So we include enumerable, and just in each, usually each is supposed to terminate, but there's nothing saying you can't write an infinite loop. And we just say yield the fiber.yield. Well, to make them more readable, yield next byte. And then we define next byte down here as fiber.yield. So when this object is used within our fiber, it will retrieve the next byte in the stream. It will retrieve bytes from the stream whenever you do any of the enumerable methods on it. So now we just need to make this. So let's just make a new one. Fiber yield enumerable.new. And what do we have here? Oh, undefined local variable or message Steam. All right. And now the tests are passing. So this is now the application logic. The rest of it is just framework and setup and stuff. And all the old tests that you saw before are still passing, so it's parsing a single SysEx message, it's parsing multiple ones. And I actually want to make this a little bit nicer. In Ruby, there's a thing called an enumerator where you can just call .next and it gives you the next thing. So I want to rename this from next byte to next. And also, when you look up here, there's no reason it should be called next byte because this class has nothing to do with bytes. We'll just call it next. But next is a reserved word. See how it's getting highlighted there? So we need to do self.next. All right, everything's passing. Now I should warn you that this is kind of risky because a lot of the enumerable methods will not work as you're expecting. I could call stream.first, and that's actually equivalent to .next. And because first, what it does is it just calls each and it gets the first value and it returns that. But if someone called first in your application, they might be surprised that it's actually reading a new byte from the stream, and now the stream has a different state than it had before. So, So there's some things to be worried about, some methods that won't quite do what you're expecting. But hey, it works, and it combines some different things. We're kind of combining the idea of an enumerator, because we can call stream.next. We're with the idea of an enumerable, so we can call .takewhile. And there are a bunch of other ones you can call, like include and select and find, I think. And we're combining, it's kind of like an I/O object also, because you read a byte from it, and that it's part of an infinite stream of bytes. So it's like we're just combining all these things together, and it works. Yeah, so
There's another 5 minutes plus for questions, right? So
yeah, there's another 5 minutes. So maybe I'll just show a really ugly trick. To scan to the next start byte, I could say stream.include start byte, and all my tests still pass. I don't think you want to do that. All right, so we'll revert that. All right. Yeah, let's have some questions. You have like a lot of time.
Okay. Really minor one. Those
Yeah.
first 2 lines of your while loop, I think you should get rid of the byte variable and combine them.
Yeah, well, byte equals stream.next.
Oh, wow, stream.net.
And I think the constant should be on the left also.
Well, where will I?
So you don't where it says byte equals, you should make it where if start byte equals stream.next.
Oh, what? Okay.
I think in general you should try to put the constants on the left so you avoid the potential error of having a single equal.
Yeah, it's safer. Just the way my mind works is this thing is a statement about the byte. I want to see the
Yeah,
byte.
you gotta get it.
All right.
You're specifically doing that to avoid the case where you use a single equals.
Yeah.
The other thing you can probably do here is if the only thing the while statement does is execute when the thing is true, you should be able to replace the true with the start byte equals string text, equal string text, and remove the if entirely.
No, we want this to be an infinite loop so we don't stop processing the bytes in our stream.
Okay, I guess so.
Yeah.
Yeah, that's okay. Right.
We could do loop people like that. There's a loop method that you can use instead of while.
The other reason to have the constant on the left actually is that that's a simpler thing, so you can start off with that and then have the more complicated thing that it's equal to on the right side.
Yeah.
The other aspect of that is the thing that is on the right side will at times be implicitly coerced to match the thing that's on the left.
Oh.
When you're doing value to value, right? So if you're doing right, so if the thing on the left is a number, and you handed a string with a number of the same value on the right side of the equals, you can right, you can get it'll tell you that yes.
Luckily, Ruby doesn't do a whole lot of that stuff.
It
But
doesn't.
it does. I guess it makes me more comfortable because this equals is actually a method call on start byte.
Start byte.
It's nicer to know that start byte is in control of that evaluation than whatever I happen to get from my stream. Yeah. Yep. So that was it.
So do you think this thing should exist? Fiber yield variable? Make a pull request?
Seems like you should have a method called take while not.
Well, or just use a different operator. Should it exist? No, it's so easy to. It does exist. I wrote it.
Right.
A good job.
I don't think, and also I think it's kind of risky and weird, and I think stuff with fibers doesn't compose well very often. Like if you have one system, you know, well,
I do like how you sort of took you sort of embedded an asynchronous approach to doing a synchronous process, right? Because the fiber doesn't need it right now. It doesn't actually care when it gets it, and as long as your code isn't actually blocked on the fact that you've got an infinite loop, that you can just turn on and turn off whenever you want. Right, you're effectively asynchronously processing the stream in a synchronous way.
yeah. Oh, that's a point I should definitely make. We turned this asynchronous interface where we receive bytes into this synchronous interface where we can ask for bytes whenever we want to and get them. And it's synchronous because we ask for the byte, and by the time this method returns, there will be a byte available. And that's what fibers allow you to do, and this kind of thing is called a coroutine. So yeah, turning asynchronous back into synchronous. I think synchronous is often easier to think about, so that's why it's attractive. All right, I guess that's it. So